We're going to pick it up where we left off last time. We're going to start with number 12. We need to do the derivative with this, but this is our first trig function that's actually got a power, so we need to start with a rewrite. So let's do, the 6 is outside, and it's the cosecant 7x that's actually raised to the power of 6. So that lets us know right there it's a chain rule because you actually have a function that's raised to a power. And you can see it a little bit better once you've rewritten it. So once we've done the rewrite, then we know it's time for the derivative, and that's when you need to note it with your f prime of x. So we're going to bring down your power. 6 times 6, we got 36. You're going to keep the function the same. You're going to reduce your power by 1. Now it's time to start applying the chain rule. You want the derivative of your function. So the derivative of cosecant happens to be negative cosecant, same angle, cotangent, same angle. And then you actually have to come in and you have to do the derivative of that angle. So it's another link in the chain. Your angle is 7x, so the derivative is 7. So we've got all these little pieces in there. Everything is multiplied. So it's all a product. There's no addition or subtraction in there. So this little 7 out here is actually multiplied times this 36. I don't know what 7 times 36 is, so let's bump that out and see. 252 is what I get. I do have this minus in there. Please don't think that's subtraction. It is not. Remember, this is all multiplication. That just happens to be the sign of that term. So it is a negative 252. And then we have all these terms here. You do have, and let's just write it out slow. This term right here is cosecant to the 5th 7x, and then that's from here. And then here you have cosecant 7x cotangent 7x. But hopefully what's clicking with you is that these are both cosecants and they're both 7x, which means we can multiply them together. That's okay. It's both cosecants and they're both same angle. That just means that we have to do to add the powers together. So that's going to be cosecant to the 6th 7x. We're going to have cotangent 7x at the end. So that one's final. Let's keep going. And we have another trig function. So we do need to start with a rewrite. So leave the 2/11ths out here. And we're going to have sine of 4 theta. And put your 3 out there. And then we are ready for the derivative, f prime of theta. Don't let the theta mess with you. It's not a big deal. Now, and don't let the fractions mess with you either. You can go slow with it if you need to. All this is 2 over 11, and then you're going to bring down 3 over 1. So if the fractions bother you, write it like that, and then you can work it out in the end. You're going to have sine 4 theta. You're going to bring your power down by 1, and then, okay, you got to say, what is the derivative of sine? Well, it's cosine, same angle, and then you got to say, okay, well, what's the derivative of that angle? Well, it's 4. Oops, not 4 theta, it's just 4. Excuse me. Okay, so now, time to clean up. Well, when you clean up, you got your little fractions here, so that's going to be 6 over 11. But we do have this 4 here. So instead of just 6 over 11, that 4 is also over 1, just like the 3 was. So 6 times 4 is 24 over 11, is what we really have. And that is sine squared 4 theta cosine 4 theta. And that's all we need. There's nothing else to clean up, nothing else to do. Okay. On number 14, we have the product rule, and we also need to rewrite because we need to get this in a workable form. So let's do x to the 3rd, and let's rewrite this thing with a fractional exponent. So we have a 1/2 power. Okay, so we're going to get a little bit of chain rule along with it. So we might we might need to write this down here so we have a little bit more space. I tell you what, let's do that. So we're going to put number 14 down here. so we don't get squished. So f prime of x is, let's just start with x to the third, and then we're going to do the derivative of our binomial. We're going to bring down the 1/2, and then we're going to have 6 minus 5x. We have to subtract a whole step down, so minus 2 over 2 gives me a negative 1/2. Okay? The derivative of the inside is negative 5. Then we've got to swap and go the other way. So I've got to have 6 minus 5x, and he's to the 1/2 power, and then you got to do the derivative of your first term. So the derivative of the first term was 3x squared. Okay. I forgot to, there we go, close that off. Looks much better now. So we need to clean up this first term. And if you notice, you do have fraction now, because if that didn't clue you off, then hopefully that little negative did. So nothing canceled out with this 2, so this 2's in the bottom. You also have this binomial that's in the bottom, so he's actually a radical. If you put him back into square root form. The negative 5 is in the top. The x cubed is in the top. So everybody's covered. And over on this side, nobody goes anywhere. You just need to clean it up. And that ends up being 6 minus 5x, the square root of it. I told you I would let you leave it there. I would love it if you went further, but I will permit you to go to leave it there, and I'm not going to count off. But I would, for those of you that are planning on moving on and going other places, you do need to understand how you can consolidate this and make it a more simplistic answer. It's not that difficult. You can get a common denominator. Your common denominator is 2 minus the square root of 6 minus 5x. This part, since it's the same thing, it's the same numerator. Over here, what you're doing is you're technically coming over here and you're saying, okay, I got to multiply top and bottom by the same thing to balance it out. So my numerator gets multiplied by 2 square root 6 minus 5x. When you do that, that gives you 2 times the outside part. So the outside parts multiply together, and you get 6x squared. The inside parts multiply together. They're the same. So that all that does is take the radical off. And so now you can distribute through that. And so you have got 36x squared minus 30x cubed. And just copy your denominator, because he's just going along for the ride. You never, ever, ever drop him off. Hopefully my board will catch up. Okay, and so then put your like terms together, and you have a negative 35x cubed plus 36x squared, and same denominator. And so for you kids that are planning on taking calculus somewhere else, you need to practice on consolidating and getting a nice concise answer. Okay, now let's keep rocking and rolling. We've got to go for second derivative. So first derivative is not going to cut it. We got to do it twice. So we got to start with first derivative though. So first derivative, we got to have our 5, and let's write them as 5 over 1. And then we're going to bring our powers down, and then we're going to have 3/4. And so that's going to be x, and we're going to step him down a whole, so whatever our denominator is, stack him up. So that's going to be a negative 1/4. Now when you clean, multiply your tops, multiply your bottoms, and that's just going to be x to the negative 1/4. Don't worry about moving him, because you fix to take the derivative again. Okay? So when you take the derivative again, come over here and actually denote that you're doing it again. So I need proper notation. Go over and beyond about your notation. So here we go. One more time. Do your derivative. You got 15 over 4. Okay, make sure your fractions are standing up straight. Don't need to flop over. Okay, and then bring your exponent down. You're going to subtract him out again. This denominator's still 4, so subtract him out. And that's going to give you a negative 5 over 4. Now you can actually sort things out. So I got a negative 15 over 16. And then whenever you sort this guy out and make him go where he needs to go, he's going to go to the bottom, and his power is 5 over 4. You can leave him like that. There are ways to actually fix that. I'll just let you leave him, but yes, you can. There's ways to to fix that. If you know that that's x on the fourth root of x, that would be great. But for right now, if you want to just leave him, that's fine. Okay, let's do the second derivative, of sine 4x to the fourth. First thing I need you to observe is that the sine does not have a power. That is just the angle, okay? So whenever you go and do the derivative, you're just doing a regular old derivative of sine. So we're going to have y prime. The derivative of sine is cosine. And it's going to be cosine of the exact same angle. But then you still have to do the derivative of the angle, which is 16x cubed. Now I'm going to write it the other way because we don't want to get any trash messed up with our angle. So that just keeps the clutter away from your angle. Now once you do that, hopefully you realize that, oh no, we now have a variable, and this calls for the good old product rule. So when we do the product rule, we're going to write down 16x cubed, and he says, oh, after you. And cosine, we need to do the derivative. Well, that would be negative sine 4x to the fourth, and the derivative of that, the angle is again 16x to the third. Okay, so then you got to do plus sign. You're going to write down, let's see here, excuse me. I did the derivative of the cosine, so I'm going to write down cosine 4x to the fourth, and I'm running out of room. Here we go. I need to do the derivative of 16x to the third, which is going to be 48x squared. There we go. So trying to clean this up is going to get interesting. I need 16 times 16, so 16 squared is 256, and that's going to be x to the 6. Now I did overlook this negative, so this negative needs to come out front, and that's going to be sine 4x to the fourth. Okay, when you clean up this other one, the 48x squared comes out front. And I do believe we got all of our pieces there. Alright, moving on. Let's go and do implicit derivatives. I tell you what, let's stop right here and we'll start implicit derivatives in the next video.